In this video, we're going to look at the normal distribution, and we're going to look at a question from June 2018. It says the lifetime in L hours of a battery has a normal distribution with a mean of 18 hours and a standard deviation of 4 hours. Alice's calculator requires 4 batteries and will stop working when any one battery reaches the end of its lifetime. Part A, find the probability that a randomly selected battery will last for longer than 16 hours. So in a question like this, we first write down our normal model. So we say L follows the normal distribution with a mean of 18 and a standard deviation of 4, which implies that the variance is 4 squared. Then we write down that we want the probability that L, which is the lifetime of the battery, is going to be greater than 16 hours. And the way we get this value is from our calculator, and we're going to do the following. We're going to press 7. We're going to choose option normal CD, and we're going to choose that the lower limit is 16. We're going to say the upper limit is 1,000,000. So we say 1,000,000 there. And we're going to choose that the standard deviation is 4, and we're going to choose that the mean is 18, and that will give me the following value: 0.69146,24617. So what I can do here on my calculator is store this in memory. So I press store, and I'm going to choose the letter A here, and that will store it to this variable called A on my calculator. Now let's see what part B is asking us. At the start of her exams, Alice put 4 new batteries in her calculator. She has used her calculator for 16 hours but has another 4 hours of exams to sit. Find the probability that her calculator will not stop working for Alice's remaining exams. So what we need to do is, we know that we want it to require for more than 4 hours, so that means it's going to be 20 hours. So it's the probability that L is greater than 20. So we can get that from our calculator. So just change the lower limit to 20, and that will give me a value of 0.308 and so on. So I'm going to write the full value out: 0.3085375,383. So now that I've got that, I'm not done with the question, because it says that she has already used her calculator for 16 hours. So it's a given that question. It's a conditional probability question, and the calculator has to last for another 4 more hours. So what we have is a conditional probability by saying that L is greater than 20, given that the calculator has already lasted for more than 16 hours. So we should have an L here. So it's written like that. So now that we've got that, we can say the following. So this is the same thing as saying we're going to have the probability that it's lasted more than 20 hours is going to be 0.3085375,383 divided by the probability that you've lasted more than 16 hours, which we know is 0.6914624,617. Now if I type that on my calculator, I can come out of this now, go to the normal screen. Now I know that the numerator is the very last answer I had, but the denominator was stored in A, so I can just press alpha and A, and that will give me 0.4462 and so on. So I get 0.446210106. Yes. So now that I got that, I need to remember this is for each of the older batteries, and you're going to see why in a minute. Older battery. So part C says Alice has 2 new batteries. So after the first 16 hours of her exams, although her calculator is still working, she randomly selects 2 of the batteries from her calculator. So she wants to replace these with 2 new batteries. So part C says show that the probability that her calculator will not stop working for the remainder of her exams is 0.199 to 3 significant figures. Now, we've got the probability that it lasts for 4 more hours, given that she's already sat 16 hours of exams. For the older batteries, which is 0.4462 and so on, but we need to work it out what it is for the newer batteries. So what we're going to say, well, that will be the probability that L is greater than 4, and that I can get on my calculator by going to menu 7. I'm going to go to option 2 for normal CD. So I want to be greater than 4 up to say 1,000,000. Remember, this is really positive infinity. Standard deviation is 4 and the mean is 18. And that will give me 0.99767. So we get 0.999767 and so on. So we want 2 new batteries and 2 older batteries. So we've got to do 0.997 and so on squared, because there's 2 new batteries, and which means times in probability. The older ones last more than 4 hours, given that if you sat the exam for 16 hours, is 0.4462 and so on, and we square that value as well, and that will give me the required answer of 0.199. And the final part. After her exams, Alice believed that the lifetime of her batteries was more than 18 hours. She took a random sample of 20 of these batteries and found that the mean lifetime was 19.2 hours. Now we call this the observed value of the mean, okay, which is 19.2, and n was 20. Stating your hypotheses clearly and using a 5% level of significance test Alice's belief. So what we're going to do, we're going to set up a hypothesis test here by saying that our null hypothesis is mu is equal to 18, meaning it hasn't changed. But mu1 is saying what Alice's claim is, which is mu is actually greater than 18. Alpha is called the level of significance, which is going to be 5% in our case, which is 0.05. And n is going to be 20. Now we call this a one-tail upper test. Okay, because it's greater than, so one tail upper test, and then we can say that L bar. Now in our hypothesis question, the normal distribution in this context, we always talk about the sample mean, so it's going to be 18, and we write 4 over the square root of 20, and it should be all of this thing squared. Okay, now once we've got that, then we can say, right, what I want is the following. We've got a standard normal curve here. This is Z. This is phi of Z here. This is 0, and we've got some value here of Z we don't know. But we know that the probability is 0.05, and because it's greater than, I'm shading towards the right hand side. So I need to work out what this value is. Now I can look at a value called the standard normal tables, the small tables in your formula booklet to find this particular value, or you can use your calculator for it. Now we can do that quite easily by saying, we go back to menu, option 7, but we have to choose the inverse normal this time. So we want 0.05. Now this will give me a standard deviation of 1, and this will give me a mean of 0 because it's the standard normal distribution, and I get a value of, now this will be 1.6449. Now this is assuming that you're on the left hand side, but we're now on the right hand side. It's got to be positive. So I'm just going to round that to 4 decimal places. Now this is the same value you get in your points distribution table in the formula booklet. Okay, now if you want to use the true value, you can. I'm just going to round it to 4 decimal places, and it's positive because it lies on the right hand side because it's greater than. So we're going to say that z equals to x minus mu, so x bar in our case, over sigma over root n. Okay, that's the formula we're going to use. So we know what z is. Z is 1.6449. Now we want to work out what x bar is, so we can write x bar here. Minus, now the mean is 18, so we say minus 18, all divided by 4 over the square root of 20. So I can manipulate that to find the value of x, and that's just going to be 1.6449 times 4 over root 20 plus the value of 18, and that's going to give me that x bar is going to give me approximately 19.5. So we can say that our critical region, okay, is x bar. Now because our alternative hypothesis is greater than, will be greater than or equal to 19.5. And then we can say, well, what's our observed value? Our observed value is 19.2. So we can say the following here. So we can say that since the observed value of x bar equals 19.2, we can say this does not lie in the critical region. I'm going to write CR for short, in the critical region. So we say we do not reject H0 at the 5% significance level. And we say there is insufficient evidence, so there is insufficient evidence to support the claim. And that's it. We are finished.